All right, so we're going to be looking at a few different ways we can work with exponentials. So we're going to start by looking at percentage changes. So let's look at the example. In recent history, Oakville's population has grown by around 2% each year. In 2016, Oakville had a population of 193,832 people. What would be what would we expect the population of Oakville to be in 2020? So in this one, it's not doubling, it's not tripling. There's a change that's a percentage amount. So whenever we work with these, we always want to convert these percents to decimals. So let's do that real quick. So 2% is, to convert that to decimal, we do the percentage over 100, 0.02. Now, if we think about that for a second, we can't use 0.02 as our b value that we're repeatedly multiplying by, because if we multiply by a number that small, we're going to get really small results. So that's not what we're doing with this number. So it's important to note that it's growing by this amount. So every year it will be the initial amount and then 2% more. So our b value is going to be 1 plus this percent change, where 1 represents 100%. So we have 100% of what we had and 2% more. So for this question, it'll be 1.02. All right, what else do we know from this question? We know that the initial amount, our starting amount, is 193,832 people. And our x value, so how many times does it grow? So it grows each year. And we know the population in 2016, and we want to know the population in 2020. So the question is, how many times has it grown between those two dates? So to find that, we can just subtract them. 2020 minus 2016, so that's 4 growths. All right, so now we can find the current population. So the function of 4 is equal to our initial amount. So we're just plugging into the general equation now, times our growth, 1.02, to the power of x, which is 4. And we could take out a calculator and calculate that, and we get 209,810 once we've rounded. So that's what the approximate current population, at least during 2020, is. So therefore, I could write a conclusion. In 2020, Oakville will have a population of 209,810. Okay, so the only real big difference in this one is our percent growth. So we're growing, so we do everything 100% plus the percent change as a decimal. Okay. And the other thing is that we're going from 2016 to 2020, so we need to convert that. Right? The total amount of time is not 2,020 years or gross, because this isn't the population on day 0. In year 0, it's in the year 2016. So we have to change our time scale a little bit. Okay, so what would the population be expected to be in 2030? Okay, well, for the most part, everything is the same for this question. So our b is still 1.02. Our initial amount is still 193,832. That's the population in 2016. Our x value does change, though. So 2030 minus 2016. So that's 14 years. So we can use our equation. So we want to find the population after 14 years. So that's 193,832 times 1.02 to the power of 14. Use calculator, 1.02 to the power of 14 times 193,832 is, and we'll have to round a little bit, but 255,757. And we can write a conclusion about that as well. So therefore, Oakville will have 255,757 people in 2030. All right. Another thing we can do is we can find the initial or the starting amount. So let's look at this question and see how that works. So a lab-grown meat company can grow a meat culture at a rate of doubling every 2 days. So it doubles every 2 days. If an order has come in for 500 kilograms of meat for 1 week from now, how much should the company start growing with? So it's asking for the starting amount and telling us the ending amount. So in this situation, we don't know the initial amount. That's our question mark. We do know how it's growing. It says it's doubling. So 2. And we can figure out how long we have. So it says the order is for a week from now, and it doubles every 2 days. So the total amount of time is going to be 1 week. Now, we don't want to write 1 because we're working with weeks and days. So, of course, we should do a conversion. So 7 days, 2 days for 1 double. So it's 7 total amount of time, 2 days per double. That's from that equation we looked at earlier today. And lastly, we know what the population or the amount needs to be at that time period. So we know f at 7/2 is equal to 500. And we want to know what the a value is. So we can write out our general equation. So we know the function is 500. A we don't know, but b we know is 2, and we know the exponent is 7/2. Now, once again, when you're writing these fractions in your exponents, make sure you're using brackets on your calculator. Okay. So how are we going to rearrange this to solve for a? Well, we're going to need to divide, because we're multiplying right here. We're going to need to divide over this 2 to the power of 7/2. Now, we could try to do that all at once on our calculator. We can also just rewrite this as a decimal. We just need enough decimal places to keep a decent amount of accuracy. So 2 to the power of, open bracket, 7 divided by 2, close bracket. And we can write this out. So 500 equals a times 11.31, and it keeps going. We'll keep 3 decimals, should be enough. And of course, we're going to need to divide both sides by that. And when we divide both sides, so 500 divided by, and I'm going to keep all those decimals in my calculator by using the answer button, we get about 44.2. So normally we don't use decimals because we're dealing with like people, insects, numbers of bacteria, like whole quantities. But in this situation, we're dealing with an amount of mass, kilograms. So you can have 0.2 of a kilogram. That makes sense. So kilograms. All right, and lastly, we should write a conclusion. So therefore, they should start with 44.2 kilograms. All right. So there's some practice questions in the back for you to work on today.